Hi, my name is Charles Timbaga, Product Marketing Engineer for Anritsu Components, and today I'd like to talk about 110 gigahertz fixed attenuators. Before we talk about the attenuators, it's probably important to understand why we need 110 gigahertz components in the first place. One of the many drivers for this necessity is 5G millimeter wave frequencies proposed, but they will move into 100 gigahertz eventually, as well as device characterization and some automotive radar. Now, if we talk about technology that exists for test and measurement equipment, generally the de facto standard used is waveguide. However, waveguides are band limited by nature, and if you're using a waveguide, you'll understand that most of the test and measurement connectors are coax, and so adapters are required, S2P de-embedding is required, and so it's not so easy to use, although it can get the measurement done. Now, attenuators are important because they're used in probably every power measurement, and that's to safeguard damage to either your device under test or even to the test and measurement equipment itself. Keeping a receiver out of compression, for instance, or lowering the power level going into a device under test to keep damage from happening. Another important use for attenuators is for impedance matching at the port. Now, having impedance matching over such a broad band frequency, like low frequency to 110 gigahertz, is actually quite a challenge. And so it's not uncommon to put an attenuator in front of a test port to help improve the VISWAR and lower the mismatch uncertainty. Now, one important figure of merit for attenuators is flatness. And what I mean by flatness is the amount of attenuation that you've set and how much you deviate from that amount of attenuation. Now, I have a Vector Star 110 gigahertz system here, and in line between the test module, we have a 10 dB attenuator. These are Anritsu's new 41W Gold Series attenuators. And so if we take a look here on the screen, we care about flatness, and we would expect flatness to be around 1 dB across the entire band. And so at 10 dB, minus 10 dB, you can see that the flatness is 1 dB. Now, this is a metrology grade component, and we do specify 1 dB flatness. And it's really important to understand why this is important, because this input into a device like an amplifier has to really be matched to understand how the characterization, and to get a better characterization, you have to understand what the deviation would be in the first place. For time domain users, I've shown also the eye diagram because you wouldn't expect a component to influence your measurement. And so having a good component with a very good eye is important, specifically because you want to have the best measurement possible. Now, for more information about Anritsu components, please visit www.anritsu.com, where we feature a catalog that has over 300 precision components. Thank you.